To understand revisions in the CES payroll data, it would be helpful to provide some context and clarity of exactly what we're trying to measure and how we measure it. As many of you know, we have a near universe count, also what we refer to as the population count of employment, via the BLS's Quarterly Census of Employment and Wages, or QCEW program, which collects employment and wage data from states' unemployment insurance tax systems, and is the primary source of both the sample frame and benchmark data for the CES survey. All businesses and government agencies that are subject to UI tax laws must report employment and wage information quarterly to their state's labor market information agencies. These UI records cover about 97% of non-farm wage and salary jobs on civilian payrolls. This map depicts the number of establishments in the United States as tallied by the QCEW program as of June of 2024. The darker the blue shade, the higher the number of establishments. This includes Alaska with the smallest number at around 250,000 to California with nearly 2 million. All told, there are over 12 million establishments that employ over 155 million people across the United States as of June of 2024. There are significant restrictions, therefore, to simply summing employment in the U.S. each month. It would be extremely cost prohibitive to do this on a monthly basis, as you can imagine trying to contact, collect, process, and tally data from over 12 million businesses each month. This would also create significant response burden for all businesses in the U.S. Doing so would also impact the timeliness of data. There is a significant need for a measure of labor market outcomes that is as current as possible, and that requires a system of operations with a quick turnaround. The statistical properties of samples allow CES to create employment estimates that are both timely and cost-effective. The CES sample surveys about 121,000 businesses and government agencies that represent approximately 631,000 individual work sites on a monthly basis. This is one of, if not the largest monthly surveys in the world, and by leveraging the statistical design of our sample, which also leverages the population data from the QCEW, we can significantly improve upon the timeliness as well as the cost effectiveness of published employment estimates. In fact, having access to the population microdata provides a huge advantage to being able to design a very representative sample. This means that the sample is not designed to be a full count of employment each month. Rather, it's meant to estimate the change in employment. If we get the change correctly, by implication, we should get the level correctly. Each year, our annual population totals, derived primarily from the QCEW data, provide the benchmark by which to gauge the annual accuracy in our estimates of change. Of course, the sample is not perfect, though. It's susceptible to the timeliness of reported data, when do and even when can survey respondents report. And we'll touch on this in a minute. There's also sampling and non-sampling error. These are errors that can occur if the sample is not representative of the universe, as well as if survey respondents report incorrect information or do not report. Uniquely to the CES program, however, we can estimate these sources of error during our annual benchmarking process, since we have access to the QCEW microdata. But since that error is the accumulation of monthly error, let's first talk about this timeliness of reporting and its impact on monthly revisions. There are two reasons why we have monthly revisions to our data. The first is the collection of additional sample, and the second is the reevaluation of seasonal factors based on this additional data. First, let's discuss the issue of the timeliness of reported data and why it leads to revisions. For one, some respondents may not provide their data to us in time for use within the current month's estimate. Related to this is that there can be reporting errors. Respondents may not provide accurate data with their initial submittal. But there are also other possible constraints. The survey requires a very quick turnaround in order to provide timely data to our users. Without this, we couldn't be one of the first economic indicators released each month. The time period for collection ranges between 10 and 16 days, but averages 12 to 13 days. It may not be possible for some respondents, therefore, to report within that window for various reasons. So, for example, if a firm pays its employees monthly, they may not be able to report their data by the deadline. As a result, CES allows for the revision of estimates for the prior 2 months in order to allow for the collection of additional sample and possible corrections to initially reported data, which has a very real impact. As a result, and in fact by design, CES estimates are considered preliminary when first published each month in order to allow for the collection of late respondents or respondents who need to correct their data. The average collection rates between 2020 and 2023 are displayed here. As a note, we have provided collection and response rates online in tabular form for several years and have just recently added these to the BLS data retrieval query online. You can see that collection garners the largest increase between the first and second published estimates, with a gain of about 21 percentage points on average, while there is just short of a 4 percentage point gain on average between the second and third published estimates. As a result, additional revisions beyond third published estimates, or 2 months prior, have not been found to be informative enough to outweigh users having to track those additional revisions. But to reiterate, the gain in sample is quite significant between the first and second published estimates. The second source of revision comes from seasonal adjustments. The CES program uses a concurrent seasonal adjustment methodology, which is just a fancy way of saying that the data through the most current month is used to seasonally adjust. This is as opposed to, say, a forecast of factors. This requires the re-seasonal adjustment of the not seasonally adjusted data, since the latter will have changed based on the additional reported data. CES publishes online the impact of both additional sample as well as the seasonal adjustments to the revisions on each month's closing. So we've laid out the reasons why revisions occur, but what is their impact? Does it actually improve the quality of the estimates? And the short answer to this is yes. One way to measure the accuracy of data is by a statistical calculation called standard error. For simplicity, this can be considered a measure of the volatility in our estimates. The higher the number, the more volatile the data, the less accurate it is. You can see that the additional sample between first and second preliminary estimates caused a reduction in the standard errors between those estimates. That means that by revising our data based on additional sample, we improved the reliability in our estimate of the over-the-month change. Again, that is the primary goal of the payroll survey. In addition, research has shown that by re-seasonally adjusting our data via the concurrent process allows for the incorporation of changing seasonality more quickly, and thereby reduces annual revisions in seasonally adjusted data as well. By including additional sample, we reduce the annual error from reporting errors, as well as error from those who did not respond or are non-response error. So to reiterate, monthly revisions are an important feature of CES estimates, since they improve the quality of the data that we provide. Unfortunately, our response errors and our non-response errors are not reduced to zero each month. We also have issues with our sample in accounting for reported births and deaths. All of this error accumulates on a monthly basis. We can therefore leverage our population data as a benchmark to gauge the quality of our sample-based estimates and to re-anchor those estimates to annual counts to prevent our estimates from drifting too far off course. This brings us to our annual benchmark revisions. Each year, CES March employment data are re-anchored or benchmarked to employment population totals that are primarily derived from the QCEW data I referenced at the outset in order to account for the accumulation of monthly error. QCEW data represents about 97% of total employment that's in scope for the CES program. The remaining 3% of data, what we refer to as non-covered employment, are compiled from outside resources, the Census Bureau, Railroad Retirement Board, as well as our state partners. These are employees of companies who are not covered by either federal or state UI law. Examples are employees of religious organizations, many nonprofit organizations and associations, students who participate in school work-study programs, employees of railroad companies, and officials that are elected to office, to name a few. The difference between our originally published CES estimates and our March employment population totals is considered a measure of the total survey error in our estimates. Another way to look at it is the monthly error that has accumulated since the prior March. Since at least 1949, the CES program has been adjusting its all-employee series with each March in order to re-anchor sample-based employment. This is an important step to help ensure the quality of our estimates since, as I mentioned before, we don't count a level each month. With the implementation of our probability-based estimation process in the early 2000s, we can actually decompose our total survey error into sampling and non-sampling error. This was a critical step in the statistical integrity of our estimates. Research published in 2009 by BLS showed that, for example, non-response error can be compiled through differences in the data reported to CES and data reported by the same set of units as collected by the QCW. Estimates recalculated using those matched reports, compared to our published estimates, reveal the cumulative error associated with reporting error. There is another shortcoming to our sample that we account for. By the time a business is selected to participate in the sample and actually starts reporting, nearly a year will have gone by. Obviously, many firms will have opened in a year's time, so the sample will have missed those births. There is also a lack of accurate reporting for firms that go out of business. We cannot distinguish between non-response and a firm that went out of business. Earlier research indicated that while the business birth and death portions of total employment are generally significant, the net contribution is relatively small and stable. To account for this net birth death portion of total employment, BLS uses an estimation procedure with two components. The first is that because of the lack of reliable reporting of either business births or deaths, only units that reported data for the prior month and the current month are used in the current month's estimate of change. This means that we are implicitly accounting for the net contribution of births and deaths, the net residual, by assuming that the growth rate of this residual is being accounted for by the reporting units. Second, the correlation between units that reported and this net residual is not perfect. This relationship can be exactly quantified, however, using historical data on births, deaths, and reported data from the QCW. This means that we can calculate the error in our assumptions in the first component and forecast the additional net residual of birth or death employment needed for the current month's estimates. That is the net birth death residual that gets published with each month's employment situation release. However, as I said, we still have error each year in each of these components, including our forecasts of the net birth death residual. So how do we actually benchmark our data? Each year, we replace our March sample-based employment estimates with universe counts of employment. In March of 2024, our population count was lower than our sample-based estimate. However, by just replacing the March with population totals, we would create breaks in our time series. As a result, we have two steps to create a continuous time series subsequent to the March replacement. The benchmark revision of March, the total error in the survey, is spread linearly backwards across the previous 11 months to April of the prior year. This is the wedge period in the chart. So March of 2024 gets 12/12ths of the total March 2024 revision. February of 2024 gets 11/12ths, and so on, where finally April of 2023 gets 1/12th of the March 2024 difference. However, this does not eliminate the break from March of 2024 to April of 2024. With the insertion of March 2024 into our time series, in addition to data from March of 2024 back, we have to adjust data for April of 24 forward in order to account for the new March level. We do this by simply moving our levels forward by the over-the-month changes that were used before, but there is one adjustment. Since we have revised Q1 QCEW data, we can also take the time to reforecast our net birth death residuals for use in the estimates for April through October. This process creates the orange time series that is completely revised based on the new benchmark level. With November, we start again with our normal sample-based estimates, where November of 24 is the third published estimate, December of 24 is the second published estimate, and January 2025 is the first published estimate. We also re-seasonally adjust our data to account for the benchmark revision and the reevaluation of outliers and models. As a part of this, we replace 5 years of data. So let's look at the March 2024 revision and the impact that it had on our data. For March of 2024, which is highlighted in yellow in this table, our final total non-farm benchmark revision not seasonally adjusted is minus 598,000 or 0.4%. This means that payroll estimates of employment overestimated employment growth between March of 23 and March of 24 by 598,000. This is a larger than average revision. The column furthest to the right shows that our prior 10-year average absolute revision is 183,000 or 0.1%. As reflected in this table, this is the largest revision over the prior 10 years, which ranged from minus 505,000 in 2019 to plus 506,000 in 2022. This would be the fifth largest absolute level revision that we've had since 1979. On an absolute percentage basis, 2024 would tie with 4 other years for the fourth largest revision since 1979. This final revision is 220,000 lower compared to our preliminary revision announcement in August of 2024 of minus 818,000. The difference between our preliminary and final data is due almost entirely to revisions in the QCEW data. This graph shows the absolute difference between the preliminary and final benchmark revisions for the prior 10 years plus 2024. On average, over the prior 10 years, the final has been 62,000, depicted by the dashed red line in the chart, different from the preliminary revision. This average has been ticking up since 2021, with 2024 showing the largest revision that we've seen in the Q1 QCEW data. But let's go back to the minus 598,000 revision for this year. We do publish a lot of data, but for benchmarking, we are just focused on the performance of our estimates since the last anchor point, which was March of 2023. Our originally published estimates showed an employment level of 157,210,000 in March of 2024, compared to 154,253,000 in March of 2023, for a gain of 2,957,000 jobs, or 1.9%. With this downward revision, we're now showing an employment level of 156,612,000 in March of 2024. This means a gain of 2,359,000 jobs, or 1.5%. Again, slightly slower than the originally published gain of 2.9 million jobs. It's important to reiterate that we did not miss the direction of labor market growth. However, we did overstate it. Labor markets continue to experience very solid growth of over 2.3 million jobs between March of 2023 and March of 2024, even with this larger than normal revision. In other words, we are not now saying there were job losses between 2023 and 2024. Gains were still quite strong, but with revised data, job growth was not as strong as originally estimated. All of the error in our estimates does not occur in just March of 2024. It's cumulative. So it's important to see where our estimates began to deviate from our population. This chart shows over-the-year changes for QCEW. You'll note overall that there are only gains over this period. You'll also note some volatility in the QCEW data from April to July of 2023. If we plot the CES over-the-year changes, you'll note that they parallel one another very closely, with the exception of the April to July 2023 period. Payroll estimates reflected the same general patterns in the QCEW, including the deceleration in job growth in July of 2023. But payroll estimates are not reflecting the same volatility in the QCEW data from April to July of 2023. And it's in this period where our estimates deviated more so from the population. However, our estimates reflected the same trend shift that began in August of 2023, after which growth stabilized, as well as the brief undulations seen in December 23, January 24, and March 24. Because of this, even with a large downward revision, we're still seeing job growth of over 2 million jobs between March of 23 and March of 24. So why did this happen? As I mentioned, our probability sample design allows us to deconstruct the total error in our survey into 2 broad categories: sampling error and non-sampling error. Sampling error occurs in any survey, and it tells us how representative our sample is. Non-sampling error comes from non-response error. These are firms that are enrolled in our sample but fail to report. Reporting error, these are firms that report erroneous data to the survey. And birth-death forecast error. With regard to sample error, one important thing we found is that the error coming from our sample selection and design is not a significant factor in this year's revision. This is important. This means that the structure of our house is solid. The fundamental design of the survey is truly representative, and that the firms we choose for selection into our sample are the right firms. This has been true of years past as well. With regard to the second category of error, or non-sampling error, neither non-response nor reporting errors had an excessively large contribution to prior years. What does appear to be the case is that on average, they all contributed to our overestimation of growth. In other words, there's no singular error that caused the majority of the revision. Rather, they appear to have collectively led to our overestimation. As an example, we can look at one of our non-sampling errors, that being the forecast error in our birth-death model. This table shows the forecast error in our birth-death model for each benchmark from 2009 to the current benchmark year 2024. So at the bottom of the table, in bold, for the March 2024 benchmark, the second column shows the birth-death forecast that was used in estimates between March of 23 and March of 24, that being 1,365,000, versus what the actual birth-death value was, which was 1,109,000, for an error of minus 256,000. You'll notice that this is in the same direction as our overall error, meaning we over-forecast how much imputation of births were needed for the current year, which caused us to overestimate growth. This made up about 42% of our total error, so not the majority of it. Again, there is a theme where the error here was within historical range, but caused an overestimation of labor growth. For context, I've also provided the history of the net birth-death residual levels and errors back to the Great Recession. A couple of things to note are that, for one, our residuals have become noticeably larger post-COVID. This reflects the significant strength in labor markets and growth in labor associated with births. However, what you will also notice is the lagged effect in our forecasts, where the actual net birth-death residuals began slowing in 2022-2023, but that same trend was not picked up immediately in our forecasts. These and earlier similar trends has caused an overestimation of net birth-death residuals in 4 of the last 5 years. This is a concerning pattern, something we addressed in our post-benchmark processing, the details of which we'll save for that upcoming portion of our discussion today. 2 additional notes here are: 1, subsequent to the relatively large forecast error in 2009, CES began quarterly rather than annual birth-death residual forecasts, which improved the accuracy of those forecasts. And second, although there are errors with our forecasts, without the use of the net birth-death residual, our benchmark revisions would be substantially larger, potentially nearly 1 million or more in many years. This chart will show the benchmark revision amounts by major industry sector and for total private and total non-farm. The top bar is total non-farm and what I've shown before. It's the sum of all major industry sectors, including government. It is reflecting a downward revision of 598,000, and it's highlighted in red since it exceeds its prior 10-year average revision. The second bar is total private, and it's the sum of the major industry sectors without government. This is a downward revision of 635,000, and it's also higher than its 10-year average revision, so it too is highlighted in red. These 2 aggregate bars are very negative because the major industry sectors are highly skewed negative. Looking at the major industry divisions that compile these aggregates, all but 3 of the sectors have negative revisions. This is an important theme. We've seen this asymmetry before in years with relatively large revisions, where rather than being normally distributed and offsetting, errors are skewed negative and have less offset. You'll also notice that some of these bars are in blue, which represent the 5 industries that had revisions that were smaller than their 10-year average. But looking at the industries with the largest downward revisions, that being trade, transportation, and utilities, professional and business services, and leisure and hospitality, stand out as contributing over 90% to the total non-farm revision. Importantly, the contributions to error vary not only according to their source, that is, what category of either sampling or non-sampling error, but also vary from year to year. That is, the category of error that is the highest will not be consistent from one year to the next. These results mean that no regularity to the contribution to error, which creates difficulty in modeling patterns by which to implement a simple solution. Thus far, we've only discussed revisions to our not seasonally adjusted data. The March 2024 revision is minus 589,000 on a seasonally adjusted basis. We previously were publishing an over-the-year increase seasonally adjusted of 2,900,000 jobs, or 1.9%. With this downward revision, we are still showing rather robust but slightly slower growth in jobs, with an over-the-year increase of 2,346,000 jobs, or 1.5%. This job shows the revisions in our over-the-month changes seasonally adjusted. During benchmarking, we have more time to thoroughly account for changes in our not seasonally adjusted data, including benchmark revisions. Also, unlike during monthly processing, annual processing provides additional time to do things like fit new models and identify different outliers within the context of this revised not seasonally adjusted data. This results in revisions to our over-the-month changes seasonally adjusted. What this table shows are the over-the-month changes as revised with this benchmark, the over-the-month changes as previously published, and the difference. So for April of 2023, we were previously publishing an over-the-month gain of 278,000, but we revised this down by 62,000 to 216,000. The good news is that our revisions are much smaller than we've seen compared to the last few years. So for example, last year there were 4 months with revisions of over 100,000, with a range of minus 109,000 to plus 135,000. This year, we only have 1 month with a revision of above 100,000 and a range of minus 137,000 to plus 21,000. The largest revision is to January of 2024, where we revised down by 137,000. Much of this was due to a larger than normal January employment decline in department stores, as well as warehouse clubs, supercenters, and other general merchandise retailers from benchmarking. Overall, you will also note the monthly differences skew negative. This is due to 2 reasons. First, the downward revision of minus 589,000. That is, our monthly changes have to cumulatively account for the March 2024 level difference. And second, adjustments made to the April to October 2024 period caused a downward revision to not seasonally adjusted data over that period, which is why you are also seeing downward revisions seasonally adjusted over that same time period. We'll now talk about and provide additional detail on the changes that were made over that period. Normally, adjustments to our post-benchmark period, or April to October, is a straightforward process. However, additional information caused the change. As I mentioned, we noted the recent historical pattern of how our forecasts were overestimating employment growth. We know that this was very likely to continue to be an issue since employment growth was slowing through 2024 compared to prior years, which means our forecasts would continue to overestimate contributions to growth from births. As a result, we made the decision to adjust our forecasting methodology for birth death to better account for the slowing growth in employment seen in the April to October 2024 period, which would not have been included in our historical actual birth death inputs. To do this, we used many of the same principles implemented for prior model adjustments, where we included the over-the-month change from the major industry sector in the ARIMA model to help regulate the amount of residual to forecast. Slower growth, i.e. a smaller growth rate from our reported sample reports, would mean less birth imputation, which would mean smaller birth death residuals. 2 changes were made based on recent research from prior forecasting adjustments. First, forecasts were done at the major industry division level and then prorated to basic level cells. Second, ARIMA models were determined by a best fit rather than predetermined using an airline model. Another important note is that we only made this model adjustment to the April to October 2024 data. Due to operational limitations, we will not be making these same adjustments to forecasts in our sample estimates from November of 2024 forward. So what was the impact of this? This table shows the cumulative revisions to our April to October estimates and the portion of that revision that's attributable to our reforecast of birth death. You can see that for the first time since 2015, we have slowed employment growth as a result of our birth death adjustment, which slowed growth by 101,000. Other effects offset the birth death forecast, so the net effect is minus 80,000 jobs. To be clear, we are not showing employment loss for April to October. Rather, This is cumulative effect to the over-the-month changes. So we're saying that there was a gain of 2,740,000 jobs from April to October, not seasonally adjusted, versus the pre-benchmark growth of 2,820,000 jobs, or a difference of minus 80,000. But this is not the first time that we've revised down. If I add the Great Recession period, we don't have the total effect because we did not keep that data, but you can see we did revise our birth death forecasts down in many years. I do want to add some clarity to the minus 101,000 in the last row. This is the difference between the forecasts used in estimation versus the updated forecasts using the adjusted forecast. If we had used our usual forecast methodology, we would have added 127,000 jobs to the April to October period. That is, the net contribution of the adjusted forecast is not really only 101,000, but rather 228,000. So to wrap things up, although revisions can seem disruptive to some users, they are an integral part of the quality control of CES sample-based estimates. Because of this, revisions have been a part of CES estimates for decades. We've also seen here that both monthly and annual revisions improve CES estimates. CES also publishes on its website extensive information on both monthly and annual revisions, as well as information on the reliability of CES estimates. We thank you for your time today, and please feel free to contact us with any additional questions that you might have.